Okay, so part B of this section, 3.2 and 3.3b, negative exponents to relate rational exponents and radicals. Um, this section we're just going to talk about reciprocals, the idea of flipping. So something like 5 is the reciprocal of 5 is 1 over 5. And why is that? It's because when you multiply 1 over 5 and 5, you'll get 1. So whenever you multiply two numbers and products is 1, they're going to be reciprocals, right? So let's take a look here. So an example. So what is a reciprocal? What I just mentioned. They do the exact same example, but with 4. So 4 times 1 over 4 gives you 1. So 4 and 1 over 4 are reciprocals. They're just a flip. Because even the 4, there's like an invisible, it's always over 1, right? All numbers are over an invisible 1, right? So another example, 2 over 3 and 3 over 2 give you 1. So these are reciprocals, they're flips. The top goes to the bottom, numerator and denominator switch positions. Okay, so what is in a non-zero number? When x is a non-zero number and n is a rational number. Okay, so here, whenever the exponent, again, we're looking at rational numbers, so we're looking at numbers that you can put as a fraction, or it could be a whole number too. So whenever it's to the power of negative exponent, you can take this and just flip it, use its reciprocal form to make it positive if you want to get rid of the negative. So you'll get a question that says leave all exponents as a positive number. So if you get a negative, all you're going to do is find like the reciprocal, like flip it over. So here, so negative n, and from the power rule, this will go to the a, and it'll go to the b as well. So they both have negative exponents, so what do? You can just flip it around. So when something's to a negative exponent, you just flip the denominator and numerator around. So let's check some examples out here. So we got evaluate each power. Okay, the first example, 3 to the power of negative 2. So if you're going to flip this one around, all you need to do is you can write 1 over 3 to the power of 2. So went the other way around. Okay. Let's look at the next example. Actually, you can evaluate this further. So for this one, you can 3 times 3 is going to be 9. So 1 over 9. Okay. Part 2 or B. Negative 5 to the power of negative 3. Okay. So again, to the reciprocal is just flipping it around. So this is to the over 1 and invisible 1. So you can write down 1 over negative 5 to the power of 3. So, and then you can write down what's negative 5 to the power of 3. So negative 5 times negative 5 times negative 5 will give you 1 over 125. Okay, it's kind of bright. I'll try writing a little bit harder so you can see. Okay, so example here. So you got a negative fraction to a negative exponent. What are we going to do here? So do the reciprocal. Flip these denominator and numerator around. So you're going to get negative. The negative still stays. So 4 over 3. Now this is positive, the exponent, because we flipped it around. And now this 3 is going to go to the top and to the bottom. Okay. And when you get a negative fraction, you can put the negative to the top or to the bottom. It doesn't matter. So here you're going to go for example, negative 4 times negative 4 times negative 4, right? Because the 3 goes to the top. Maybe I'll show that step as well. So negative 4 to the power of 3. And at the bottom, we got 3 to the power of 3. And then we got negative 4 times negative 4 times negative 4, negative 64 over 3 times 3 times 3, which is 27. Okay, that's kind of clear. All right, last example here on this page. 10 over 3 to the power of 2, negative 2, sorry. So you see a negative 2, you want to find a positive, you want to make the exponent positive, you're going to find the reciprocal, right? So 3 over 10 to the power of 2, and then finally the 2 gets distributed to the top and the bottom. Right, so 3 times 3, 3 squared, it's going to give you 9, and 10 times 10 will give you 100. Okay, let's go next page. Okay, so next page here. To evaluate a power with a negative rational fraction exponent, Evaluate 8 to the power of 2/3. So this is the same sort of idea. Just go with this example is already done for us. Again, when you have a negative exponent, just put it over, uh, well, flip it around. So again, there's a 1 here. So flip these around to get the reciprocal. So 1 over 8 to the power of 2/3. That makes the exponent positive now. So now we got our positive exponent, and it's to a fraction here, right? So remember we went over in the previous video, how do you make the fraction to a radical? You take the root and you swing it to the outside. You put this base number in the radical symbol here. And by the way, this number that inside the radical is we call it the radicand, right? So I've been calling it the base, it's radicand to the power of 2. Okay, so now simply you evaluate the bracket first. What number multiplied by itself 3 times gives you 8? So the cube root of 8 is 2. So 2 times 2 times 2. And then now 1 to the power of, or 1 over the power of 2 to the power of 2. So 2 times 2 is 4, 1/4. Okay, hopefully I didn't mumble that too much, but we'll look at 4 examples, and then I think you guys should be experts at this kind of stuff. Okay, so let's look at the first example. We got 9 over 16 to the power of -3/2. So here, just notice that first thing we're going to do, we see a negative exponent. And in these types of questions, usually it means we need to find the reciprocal to get this positive. So flip this around. So 16 over 9. And then remember this 3 over 2 gets applied to both the top and the, and the bottom. So 3 over 2 and 3 over 2. Okay. So now here we got the numerator and the denominator with this fractional exponents. And what we're going to do here is we're going to put it in radical form. So at the top you got the 16. And then swing the 2 around, put it in brackets to the power of 3. And then we got the 9 here. So let's do this one. Again, to the power of 2. And we got our 3 here. So do the inside first. So what number multiplied by itself gives you 16? So 4 times 4. So we got 4 to the power of 3 at the top. And then what times number multiplied by itself gives you 9? So it's 3. Again, to the cube. So finally, you're going to do the cube root of the top and the bottom. So 4 times 4 times 4 will give you 64. Oops. And now we got 3 times 3 times 3, which will give you 27. And that will be our answer. Okay. So next one here, we got same sort of idea here. We got a fraction to another fraction to the power of this fraction here. So it's a negative exponent. So first thing we're going to do is flip it around. 36 over 25. And this gets distributed to the top and the bottom. So 1 over 2 here, 1 over 2 here. And simply, this is just the same thing. Whenever you have a number 2, the exponent 1/2, that's the same thing as just the square root, because the 2 is getting swung here, right? And there's invisible 1 here. So, and again, I'll just do this on purpose. I'm not writing the 2 here. Whoa. Hopefully people can see that. Let's see if the light. It's actually better without the light. Okay. So now you're just going to find the square root from the top and the bottom. So again, you don't have to write the 2 here. So square root of 36, 6. Square root of 25 is 5. Okay. Running out of room here. I'll try to write really small here so I can fit the last one. So this is 16 to the negative, what is that, 5/4. Okay, so first off, we're going to flip this around. This is to the 1 at the bottom, so I'm going to put 1 over 16, 5 over 4, right? Which is equal to 1. And put it in radical form, swing the root to the side. 16 and a 4 here, and this whole thing's in brackets to the power of 5. So now what we're going to do is you're going to say, okay, what number multiplied by itself 4 times gives you 16? So 2 times 2 times 2 times 2. So it's going to be 2 at the bottom. And again, this whole thing is to the power of 5. And now you're just going to do 2 to the power of 5, which is 2 times 2 times 2 times 2 times 2, which is 32. Yeah. Okay. All right, last one. Okay. This one might seem tricky. So the only tricky thing is this is a decimal. So whenever you have a decimal like this, it says hint change 1.5 to a fraction in lowest terms. So fraction, you should know how to do decimals to a fraction. We didn't really talk about it, but it's a grade 8 material, I think. So you can put this number over 100. But some of the common ones like this you should remember. So negative 1.5 is just going to be 3 over 2, right? So negative 25 to the power of negative 3 over 2. So once we get it to this point, um, what you're going to do is just get the exponent to be positive. So that means find the reciprocal of this, which is just flipping it around. So we got 1 over negative 25, 3 over 2. Okay, and now what you're going to do is just swing the 2 around, put this in as a radical form. So we got equal, 1 over square root of negative 25 to the power of 3. Okay, so this part you can't do. So the negative, I kind of messed up here. So what number multiplied by itself gives you negative 25? So this is actually impossible. You can't really do this. Because 5 times 5 or negative 5 times negative 5 will give you positive 25. So over here, this negative is to the fraction, so you can put it at the top. So I shouldn't have put it here. I'm going to erase this, but I have a pen, so I'm just going to do that. Put it at the top. Okay, so negative is on the 1 now. So square root of 25 is 5, so 1 over 5, and again, it's the power of 3. And then 5 times 5 times 5 is 1 over 125. Okay, good. All right, let's keep going.